This short video concerns water flow in sand. The flow box is constructed as shown here with sand on both sides of an impermeable wall. In the bottom of the wall, small holes are made to allow the water to flow through to the other side. However, these holes are closed in the first place with a metallic bar. Uniform sand is filled on both sides of the wall. A filter layer is placed on the bottom, on the back side. Imagine now that a heavy rainfall occurs on the back side of the wall. Due to the filter layer, a uniform parallel flow occurs on the back side from the ground surface towards the filter layer. As more rain falls, the sand on the back side will be saturated and the water table rises to be above the ground surface on the back side.
We will now demonstrate the parallel flow in this flow box here. The box is constructed as sketched in the drawing. The metallic bar here ensures that the water from the back side will not flow towards the front side. The soil is dry from the beginning, which makes it easier to follow the parallel flow from the top towards the bottom. The water is now filled in the top and the parallel flow begins. The soil is now water saturated here on the back side, and the water table is found above the ground surface.
When the metallic bar is removed, water will start flow from the back side towards the front side, and the water level will rise on the front side as well. This occurs quite rapidly. Due to the large difference in pressure levels between the two layers, the velocity of the flow will be quite large. Large velocities might lead to lifting of sand particles on the front side. This phenomenon can be quite critical for real constructions.
Now let's see what happens in the flow box when the metallic bar is removed. The situation here is as we left it, with saturated sand on the back side and the groundwater table above the ground surface. The sand on the front side is still dry. Pay attention to the soil grains here on the front side, especially in the beginning after the metallic bar is removed. The metallic bar is now removed, and it is found that the impact is largest in the beginning. It is demonstrated that the sand grains are actually lifted due to the flow from the back side towards the front side. The flow continues as long as there is a difference in the water table from the back side and the front side. When the water table on the back side and the front side are equally, the water flow stops. Yes.
Let's just see once again how the sand grains on the front side are affected when the metallic bar is removed.